Hello students, welcome to the channel The Sunil Academy, and now again here to discuss about trigonometry. We'll discuss here about the basics of trigonometry, how it started and what's going on trigonometry. So let's start trigonometry. So by the word trigonometry you can understand that trigo, it is related to tree related to 3, and it's related to triangle. So basically we discuss about trigonometry on the basis of a triangle. So which triangle? So that triangle is right angle triangle. There may be a question that why right angle triangle? Why not equilateral triangle, isosceles triangle, acute angle triangle, obtuse angle triangle? Why right angle triangle? So there is a particular property in right angle triangle, that in a right angle triangle the square of the side opposite to right angle is equal to the sum of a square of other two sides. So this particular property is available only in right angle triangle. This is not available in other triangle. So that is very unique property. And the other property is, on the basis of right angle triangle, you can understand that in a right angle triangle that the concept of horizontal line and vertical line, this is indicated by actually the right angle triangle. When you put a perpendicular to the line, then that is vertical line and that is horizontal line, and joining these 2 points we get a triangle, that is right angle triangle. And basically in any triangle we consider this line as a base and this line as a height, or we can say that altitudes. Basically altitude is perpendicular to the other side, that is called base. Okay, so if you try to find the area of triangle, then we get that area of right angle triangle is half into perpendicular sides, that is base into height, right? You can follow this formula to other triangle also. ABC, if you put perpendicular from A to BC, then AM will be perpendicular, AM will be, that is altitudes, and the side BC will be base. If you draw perpendicular from B to side AC, then BN is perpendicular, that is BN is altitudes and AC is base. So the side on which perpendicular is drawn, altitude is drawn, perpendicular is drawn, then that particular side called base, and that perpendicular line called altitudes. So in a triangle there are 3 altitudes and 3 base, corresponding base. There are 3 altitudes, and corresponding to that altitudes the side is corresponding base, that is BN is altitude and AC is corresponding base, that is AC is base corresponding to BN, and BC is base corresponding to AM, and AB is base corresponding to CP. So to find area of triangle, here will be half into AC into BN, base into altitude, here half into BC into AM, and here half into AB into CP. So in this way we can find the area of triangle, no matter this triangle is isosceles, equilateral or a scalene. So basically these formulas comes from right angle triangle. Okay, That's why this is very unique property. On the basis of this property, in equilateral triangle, we find the area of triangle. A particular formula for area of triangle, that is root 3 by 4 into a square, and height equals to, that is this one, in equilateral triangle, because of all the sides are equal, that's why all the altitudes are equal. Okay, so in this way there are so many properties related to right angle triangle, and the property that says that the square of the opposite sides of right angle is equal to the sum of a square of other two sides, and this particular property is given by Bodhayan, mathematician, who is Indian mathematician. But he didn't give the mathematical proof of that. He gave such a practical proof of that. Okay, but Pythagoras given the mathematical proof, and incorrectly it is said that Pythagoras theorem, which was called in ancient India Sulvasutraj method, you will discuss, that is Sulvasutraj method, but it is renowned, it is known by Pythagoras theorem. So basically we are going to discuss Pythagoras theorem, and on the basis of that we will discuss the base of trigonometry, right? So what is the basic idea about right angle triangle? That there is right angle triangle at B, and what is the concept behind the perpendicular, hypotenuse and base? So we all know that hypotenuse is hypotenuse is opposite to right angle triangle. So this is H, hypotenuse. Okay, and the common perception is the vertical line. This is vertical line, that is perpendicular, and this is horizontal line, that is base. But we want to clarify that this is right angle triangle. So basically what you are trying to say, that this vertical line is perpendicular and this horizontal line is base. Okay, so now what will happen if we move this anti-clockwise? So what will happen? This is perpendicular and this is base. Before some moments ago you were saying that this is perpendicular, and now you are saying that this is base. So how is it possible? So because it's possible, because you're defining this perpendicular and hypotenuse is perpendicular and base is very wrong way. Why I'm saying that? So at the particular moment you are saying that this is perpendicular, and other moment you are saying that this is base. So there may be some clarification, that when will you tell this is perpendicular and when will you say this is base? So basically it depends on these two acute angles. Okay, this is perpendicular, of course 90°. So and the summation of A and C will be of course 90°. If not, then will not be the sum of all the angles 180°. So it is necessary that if this is 90, of course this is 90°, then this will be something, this will be something, but the sum of these both angle A and C will be 90 degree. So this is less than 90 degree, and of course this is also less than 90 degree. Suppose this is 40 degree, so of course it will be 50 degree. Okay, and this is 90 degree, so 40, 50, 90, and 90 plus 90, 180. So of course 40 is acute angle and 50 is also acute angle. So A and C is acute angle. Okay, so basically what is the matter behind that? At the particular moment you are saying that AB is perpendicular, and other moment you are saying that AB is base. Okay, so basically the reason is in both the cases hypotenuse will be same, no matter. So AC is hypotenuse in every case. If in this way this is hypotenuse, and if you change this, so of course is opposite to 90 degrees, so of course it will be, this is in every case, no matter here in this way and no matter in this way, in both the cases this side is opposite to right angle, that's why it will be hypotenuse in each and every cases. Okay, so in case of hypotenuse there is no any contradiction, but in the case of perpendicular and base, so for particular acute angle we'll define perpendicular and base. So if we are talking about angle C, then the opposite to that particular angle will be P, right? And the adjacent side will be base. Got it? The opposite for any particular angle, the opposite angle is P and the adjacent angle is B. In other moment, when we are talking about for angle A, then of course opposite to angle A will be P, that is perpendicular, and corresponding to A will be base, that is base. Okay, so in this way, when we'll called AB as P when we are talking in the respect of C. Okay, so when we are saying that when we are talking in respect of angle C, then AB will be P perpendicular, and when we are talking respect to A, then AB will be base. So AB is perpendicular and AB is base also, but it depends on in respect to which angle we are talking. If we are talking in respect of angle A, then of course for A, AB is base, and if we are talking in respect of angle C, then the opposite side AB is P. So basically we can say that for angle A, H is fixed, P is for C. At first we are talking about C. So for angle C, H is AC, okay, and AB is P, and the BC is base. But when we are talking about in respect of angle A, then H is fixed, of course, but P is BC and AB is base. So for a particular angle C, AB is perpendicular, but for the other acute angle, AB is base. For a particular angle, BC is base, but for another acute angle, BC is perpendicular. So in this way, for which acute angle we are talking about, right? On the basis of that, we'll decide what will be the perpendicular and what will be the base. Okay, so now if we talk about a particular angle, this one C, then the same thing, uh, same properties will behave like for the angle A also. So now we'll discuss about a particular acute angle, and you'll follow that all the things that will be applied to the other acute angle also, right? So here we have generalized the angle that we can name that the angle for by theta, alpha, beta, gamma, psi, delta, and everything. There are so many symbols in mathematics. That is a Latin symbol, Greek letters, that is. Okay, so we named the angle C as theta. So for theta, h is fixed because hypotenuse is always fixed because it's opposite to right angle, and the perpendicular is opposite to that particular acute angle, and the base is adjacent to that particular angle. Or we can say that after naming these two sides, the third side is base, right? So here basically we are going to talk about trigonometric ratios. Why we are saying that? Okay, so the ratio of perpendicular and hypotenuse for angle theta, P is perpendicular and H is hypotenuse. So the ratio of P by H is named sine of the angle theta. Got it? Okay. In the similar way, the ratio of B by H is said to be cosine of the angle theta. In the same way, P by B tangent of the angle theta. Okay, got it? So basically P by H, B by H, P by B are ratios, and the mathematician named this ratio as P by H is sine of that angle. Sine is basically the name of ratio. The ratio of P by H is sine, called sine, and the ratio of B by H called cosine of that particular angle, because P by H is decided for particular angle. That's why we are saying that sine of the angle theta, cosine of the angle theta, and tangent of the angle theta. Okay, so it was very big to pronounce everything all the time in mathematics. That's why the mathematician abbreviated in short form. What abbreviated that? Sine of the angle theta written as sine theta. Here doesn't mean sine multiplied theta. Basically sine theta is meant by sine of the angle theta, and the cosine of the angle theta abbreviated as cos theta. What is meant by cos theta? It's not cos multiplied theta, it is meant by cosine of the angle theta. In the same way, there is tan theta. In the same way, tan theta is not tan multiplied theta. Tan theta is basically the tangent of the angle theta. So these are the basic trigonometric ratios. Okay, and it was discussed by our mathematician Aryabhat, who discussed this in Aryabhatium in approx 500 AD, and yes, 500 AD. Okay, and after some time it translated into Arabic by Al-Khwarizmi and other Arabic mathematicians, and then after that it translated into Latin language, and in this way it propagated to all over the world, all the Europe. Okay, and a mathematician named that that is sinus after translating from Arabic to, actually in Indian mathematician in Aryabhatium it was Jiva or the Jiva, and it is said in short that Jiva or Jya. Okay, basically it is said that Jya or ardhja, ardhjiva, and in short called ja. And after translating in Arabic, it was the same, but after translating from Arabic to Latin, it changed into sinus. It changed into sinus, and then after Edmund uh, Gonter is what like it is like that, a mathematician, an English mathematician, changed it sinus to sine, and then after some time it abbreviated to sine theta. In the same way, koti jiva, this is ardha jiva, and in short we can say ja. And the second one was koti jiva, which translated by the Edmund Gunter in English mathematician, that is cosinus, and it changed to cosine. Okay, and now cosine of the angle theta is abbreviated cos theta, and then after came tangent of the angle theta, and it is also abbreviated as tan theta. So basically these are the ratios, and we are talking about this ratio in trigonometric. That's why these ratios sin theta, cos theta, tan theta are called trigonometric ratio. Of course, if we are saying that p by h is sin theta, so of course what will be called if we do h by p? In that particular sense, if there is h by p, this is said cosecant of the angle theta, and in short cosec theta. Got it? And h by b, that is secant theta, secant of the angle theta is sec theta, and b by p is called cotangent. That is cot theta. So basically there are three, or we can say that two. There are two basic trigonometric ratios, and we can include tan theta also. Why I am not including this into this? Because of tan theta can be written in the form of sin by cos theta. So basically sin theta is the basic form. Okay, so here if we write p by b, okay, why I am saying like that? So it can be written as p by b can be written as p by h, b by h. Basically we can cancel h to h, so we'll get the same thing, p by b. That's why we have written here. And now p by h can be written as sin theta, and b by h can be written as cos theta. That's why I say that tan theta is not basic trigonometric ratio, because it can be changed in the form of sin theta and cos theta. In the same way, cot theta can be written as b by p, so we can write b by h, and p by h. So after cancelling h to h, we will get the same thing, b by p, and right, b by h can be written as cos theta, and the p by h can be written as sin theta. So basically cot theta is also can be changed into in the form of cos and sin. So that's why we didn't say that tan theta and cot theta is basic trigonometric ratio. So sin theta and cos theta is basic trigonometric ratios, and it was discussed earlier in ancient Indian mathematician by Indian mathematician Aryabhat in his book Aryabhatium. Okay, and here cosec theta and sec theta is not basic trigonometric ratio. Why I am saying that? Because cosec theta is reciprocal of sin theta. Sin theta is p by h and cosec theta is h by p. Cos theta is b by h and sec theta is h by p. So basically these are reciprocal to each other. Okay, and of course cot theta and tan theta is also reciprocal to each other, because tan theta is p by b and cot theta is b by p. So these are reciprocal to each other, and we know that the product of reciprocal is 1, right? So of course sin theta into cos theta, sin theta into cosec theta 1, sec theta into cos theta 1, and tan theta into cot theta 1, because these are reciprocal to each other. So we can write here that sin theta into cosec theta 1, cos theta into sec theta 1, tan theta into cot theta 1.